This is the orange juice that I squeezed out, and so this is citric acid basically, and I'm looking for more of a red color because it's lower on the pH scale, so I'm gonna try this. It's so exciting. Ooh, okay. That's cool. So it turned red. That's so nice. Okay, so now I'm going to do the exact same thing, but with soda or Coke. So for this, I'm also expecting a darker color in red or maroonish or something. Oh, okay. So if we look closely, then we can see the color change. If you can see that red shining through like that. So it's maroonish. I'm gonna see what happens if I mix this up. Okay, so let's mix this. The color isn't coming to the top or anything. But you can just see the red over there. Okay, and for the $1 million question, so I wanted to see whether this is kind of like an experiment in an experiment, because my actual experiment is seeing which household items are more acidic, and, well, not really dangerous, but which are more acidic. So I wanted to try out milk because I wasn't really clear whether it was a base or an acid, and if it was an acid, then how strong of an acid was it. So I guess we're gonna find out. And if nothing happens, then okay. Oh, it's turning purple. Okay. This means that it is, wait, I'm gonna continue adding some more. Ooh. It's turning purple. That's cool. So, wait, but doesn't, turning purple, no, turning blue, and green means that it is a base, and then turning, pink or red means that it's an acid. So, and then, the blue is in the middle. So, I'm guessing this is on the acid side. I'm not entirely sure because I did some research and it did say that milk is an acid because when it expires then it tastes sour. And Miss also explained this in class. So I'm thinking, I'm actually kind of sure that this is an acid because of its purple color. That was cool. That was a fun experiment. Okay, and for our next item, we're going to test filtered water, which I'm already expecting a blue because it's 7 on the pH scale, which means that it's neutral. So let's see. Yes, exactly. So I feel like why this happens is, oh, it kind of turned purple over here, but I feel like why this happens is because the cabbage juice is already blue, and then going inside the water, which doesn't really have any reaction to it, it also stays blue. Oh wait, it turned kind of purple. Strange. That's interesting. Miss Darby, why did this turn purple in the end? I thought it was supposed to stay blue. It's filtered water. Regular filtered water. Okay, so now I'm using Fanta. Fanta isn't really sour, but neither was Coke. I'm not sure what I'm expecting. I think it's going to be relatively the same to the citric acid, the freshly squeezed orange juice that we did before. So let's see. Yeah, so that is... Oh, okay, it's actually a bit of a darker shade. Let's go and compare the two. Yeah, you can see that the freshly squeezed orange juice is a little bit lighter, and then this, okay, that makes sense because this probably has added sugar and things which makes it fizz, which makes it more acidic, and then this one is natural, so then it wouldn't have all those extra added ingredients. So these are all of the acids that I tested. I'm still really confused about the filtered water turning purple, but yeah. Even though my mother actually did suggest that because the original color of the cabbage was purple, therefore the water is now purple, but in any of the videos that we watched, they didn't turn purple for them, they were still blue, so I'm so confused. But yes, this is the Coke, the Fanta, the fresh orange juice, milk, and the water. And now I have no idea what I'm going to do with this cabbage juice. Okay, so I made my conclusion for what I think. So as we can see, the Coke went like a maroon color, and we didn't even, the color change wasn't, sorry, I'll stop moving, the color change wasn't really visible. It was like just a really, really dark shade of red. So I'm thinking that that's really low on the pH scale. Then we have the Fanta, which was like a bright red. And then after that we had the orange juice. The reason why the orange juice and the Fanta were both bright red is because they both had citric acid in them, which is a strong acid, and that's why it's really low on the pH scale. And the reason why it's low on the pH scale is because it's further away from 7, which is neutral. So the farther away an acid or a base is from that neutral point, which is 7, the stronger it becomes. And so these two, the Fanta and the freshly squeezed orange juice, even though I don't know their numbers, I can see by the color that they're really far away. So anything which is like pinkish or kind of purplish is closer to 7, and then something which is reddish is farther away from 1 to 6, because that is the range for acids. Then is the milk, which turned purple, surprisingly. So then I'm thinking that it is an acid then, because a base is blue to green, and an acid is like pink and red and purple. So purple that means it's not a strong acid at all. It's really close to 7, because that color is neutral. But then the water, which is, as I mentioned twice before, it also really stumped me. I'm not sure. It was supposed to be blue because it's supposed to be the neutral. It's supposed to have a pH of 7, but as we can see, it turned purple, which means that, I don't know, maybe there's some problem in my water, but it's Nestle. I don't know. Maybe I can retry that with my kitchen tap next time and see if there's a difference. Yeah. So that's what I wanted to say. So what I found to be the most strong acids were the Coke, the citric, the orange juice, and the Fanta, yes. So yeah.